morning, myself from Shakti Vidyaniketan Marga. During the last lecture of General Science, we have started the new topic. The name of the chapter is Property of Natural Resources. So, in that, you know that there are three natural resources we have seen in the last year, that is land, water and air. Okay. So, first we have learned the property of air. During the last lecture, we have seen two important properties of the air. Okay, which is first one is air having mass and weight. As other objects also have mass and weight, air having mass and weight. Okay, and the second property is that the atmospheric pressure is the same in all directions. Air having atmospheric pressure. Okay. Air having pressure, and the pressure of the air it is called as atmospheric pressure. Okay. So one question is given on page number 17. Is there any atmospheric pressure on the moon? What is the answer? Obviously the answer is no. Why? Because the air is not present on the moon and there are no gases on the moon. Therefore, there is no atmospheric pressure is possible on the moon. Okay. Then one important information is given in do you know, under ordinary conditions atmospheric pressure of at sea level is about 1,01,400 newtons per square meter. So the atmospheric pressure which is present at the sea level is how much? 1,01,400 Newton per square meter or meter square. Okay, square meter. So in short, it is written as 1,01,400 Newton per meter square. Okay, so Newton per meter square is the unit of measurement of the atmospheric pressure. Okay, so the atmospheric pressure which is present near the sea level or below the sea level is 1,0400 Newton per meter square. Okay, so Newton per meter square is the unit of measurement of atmospheric pressure. Okay, and this atmospheric pressure is measured by the instrument. It is called as barometer. Okay, so barometer is the instrument of measurement of the atmospheric pressure. So when we measure the atmospheric pressure near the sea level by the barometer, it becomes 1,0400 Newton per meter square. Newton per meter square is the unit of measurement of atmospheric pressure. Okay. So Newton per meter square is the unit of atmospheric pressure. It can be measured with the help of an instrument called as barometer. As we go higher above the sea level, atmospheric pressure decreases. For example, here is the sea. And for example, upside there is one mountain near this. So the atmospheric pressure is high. Means near the sea, the atmospheric pressure is high, and mountain is upside. Means as we go from downside to upside, so atmospheric pressure is low. Understand? So atmospheric pressure decreases from down to up. Understand? Means when we go downside, the atmospheric pressure is high, and when we go upside, the atmospheric pressure is low. Okay. So atmospheric pressure decreases when we go higher to the sea level. Okay. Now there is one information regarding the great scientist. The name of the scientist is Daniel Bernoulli. Put forth the important principle in 1726. That is, pressure of the air decreases when the velocity increases. What is mean by velocity? Velocity means the speed of air. Means you know that gas or air consists of small molecules. Okay, so air molecules. When there is a movement of molecules, it is called as velocity of the air. So that velocity increases while the pressure of the air increases with its velocity decreases. Means when there is a low velocity or low of the air, there is high atmospheric pressure, and when there is a high velocity of air, there is low atmospheric pressure. Understand? So if the body is moving through air, the air pressure decreases. Okay, perpendicular to the direction of the motion, and the air of its surrounding flows rapidly from higher pressure to lower pressure. So this statement means if a body is moving through air, the air pressure decreases. Means when the body of any object is moving through the air pressure decreases perpendicular to the direction of the motion, and the air its surrounding flows rapidly from higher pressure to lower pressure. This statement, when you want to understand this statement, there is one activity is given. So if you learn or understand this activity, you are able to know the statement which is given upside, okay, in that box. So what is the activity? Now take some water in the plastic cup and hold a straw. Now there is one diagram is given. So I will explain you first that diagram, and from that diagram and that explanation you are able to understand the concept of atmospheric pressure. Okay. So in your book on page number 17 there is one diagram. So in that diagram you have seen one glass. Okay. For example, this is a glass. Okay. In that glass you fill 1/3 of water. Means the water is present inside the glass. You fill that glass up to 3/4 level. Okay. So take some water in the plastic cup or a plastic glass and hold a straw upright into it. So you can keep one straw inside like this. Okay, upright condition. Okay, means in straight condition. So this is the one straw. Now next one, hold a small piece of another straw near the upper end of the first straw. Now you keep one more straw at the upper end. Means this is the lower end of the first straw, and this is the upper end of the first straw, and you keep one more straw here. Okay. So hold the small piece of another straw near the upper end of the first straw. Now this straw is perpendicular to the second straw. Okay. So this is the meaning of the perpendicular condition. Okay. So for example, this is the first straw and this is the second straw. So we say that second straw is perpendicular to the first straw. Okay. So this is the perpendicular position of the second straw with respect to first straw. Okay. So hold the small piece of another straw near the upper end of the first straw and perpendicular to the first straw. Blow hard through the small piece of straw. So you blow from here with the help of your mouth. Okay. So here is your mouth. You blow in this direction in the second straw. Okay. Then you will see a fountain of water. Why did this happen? Okay. So when you blow the air from this end of the straw with the help of mouth, you will see the fountain like this. Okay. The fountains will come from the first straw. So how it is possible? First understand this principle. So this principle is called as Bernoulli's principle. So how this fountain will form from the first straw. Now how this process occurs? On blowing through the straw, the air at its open end is pushed away, and then the pressure of the air at the opening goes down. So when we push the air by blowing the straw with the mouth, so the air comes to this end. Okay, firstly, then it pushes away and the pressure of the air at the opening goes down. As the pressure of the air near the upper end of the air straw becomes less. So here there is a less pressure. Okay, and in the lower side there is high pressure. Okay, when we blow the air from this straw, the moment of air takes place, and here the pressure is created, but this pressure is low because upside there is a low pressure and lower side there is a high pressure. Okay, there is low pressure at the upside. So what happens? As the pressure of the air near the upper end of the air straw becomes less than atmospheric pressure, the water in the cup is pushed from where the pressure is higher to where it is lower. Okay. So the water which is present inside the glass, it pushed from this straw upside. Okay. Why? Because you know that movement of the molecules or particles always takes place from high pressure to low pressure. That's why by blowing the second straw, the pressure is created, means at the lower end there is high pressure and at the upper end of the first straw there is low pressure. Okay. So therefore the water molecules which are present inside the glass, they start moving from the first straw upside because the movement takes place always from high pressure to low pressure. Therefore this movement takes place from the straw and we will see the fountain upside, means this water goes outside by the upper end of the first straw. So therefore we have seen the fountain. Understand? So this concept means the movement of the air from high pressure to low pressure, it is called as Bernoulli's principle, because this atmospheric pressure or this pressure moves from means high pressure is moved to a low pressure. This principle is given by the Daniel Bernoulli. So this is called as Bernoulli's principle. Okay. So one question is given: what is the effect of increased temperature on the pressure of air? Means when there is a high temperature in the air, what is the effect of pressure of air? So answer is, as the temperature increases, the pressure is also increases. Why? Because as the temperature of the surrounding increases, the energy of the gaseous molecules, means you know that in the air there are small molecules of the gases. So this gases energy of the gas molecules also increases. So therefore, for example, if there is one container is there, okay, this is the sun. For example, during the daytime there is high temperature. So the air which is present or air molecules which are present in the atmosphere, so they struck fastly on the container or any object. Okay. So these are the air molecules, and this is one object or it is also called as container. Okay. So these air molecules which hit to the or striking to the container due to high temperature. Okay. So therefore, as the kinetic energy of the gaseous molecules also increases during the daytime, as the temperature increases, the energy of the air molecule increases. Therefore, they move very fastly from one place to other place. And when these molecules strike to any container, at that time the pressure is high on that place. Okay. So therefore, as the temperature of the surrounding or temperature of air increases, the atmospheric pressure is also increased. Understand? So this is about the atmospheric pressure. Now, when there exists a difference in the air pressure at two different places. For example, there are two places. At one place there is high atmospheric pressure or high air pressure, and on the other place there is low pressure. So at that time the air starts to flow from higher pressure to lower pressure. For example, two places. Here is one place, here is second place. So here is high pressure at this place, okay, high pressure, and here is low pressure. So how air will flow in these places? So the air pressure is always flows from higher pressure to lower pressure. So air molecules always flow from this direction to this direction because the air is flow from higher pressure to lower pressure. Okay, for example, this is the first place and this is the second place. So air flows from first place to second place. Okay, because on the first place there is high pressure and on the second place there is a low pressure. So air will always flow from high pressure to low pressure. So when we feel the breeze in the nature or in the atmosphere, so that movement takes place from higher pressure to lower pressure. Therefore, we feel the air, or it is called as breeze. Okay, wind blowing. Thus, winds are an effect of the difference of air pressure. So when we feel the air or wind, or breathe when the movement of air takes place, okay, from higher pressure to lower pressure. Okay, so the detailed information of air pressure you will learn in the geography in the chapter of winds. Okay, now one more activity is given. One glass, instead of water, you put ice cubes inside it. Means you know that in the refrigerator the ice cubes are there. So these ice cubes you put in the glass. Okay, for example, when we keep the ice cubes like this in the glass, what will happen? You already done this activity, I think. So when you put the ice cubes inside, so you will find that small droplets are seen outside the container or glass. Okay, small water droplets are formed on the outer surface of the glass. Why this? How this will happen? Okay, so take ice cube in the glass up to 3/4 of its height. Now observe what happens if the water droplets appears to the outside of the glass. Yes, okay, so we have seen the water droplets on the outside. So how this process occurs? Due to the ice cubes in the glass, the air surrounding the glass cools down. Now you know that the ice cubes are present inside the glass. So that the air molecules which are present outside the glass near to the surface of the glass, they cool down due to the ice. So that's why the air is converted into water vapors, okay, or water molecules due to condensation process. Okay, so air molecules becomes water droplets because the air molecules cool down due to the ice which is present inside the glass, and due to the cooling of the air, that air molecules or gaseous molecules converted into water molecules. So therefore water droplets are found, and this process is called as condensation. Means when gas state or gaseous state is converted into liquid state, that process is called as condensation. Okay, means gas is converted into liquid, so it is called as condensation. Okay, so due to condensation or due to the cooling of the air molecule, it is converted into liquid form or water droplet. It is called as condensation of water or gas. Okay. So due to this, the water vapors in the air cool down and it is condensed and get transformed into water. So it is the water that connects the outer surface of glass. And due to this condensation or this cooling effect, the gaseous molecules are converted into liquid molecules, and therefore these liquid droplets are found on the outer surface of the glass. This is called as condensation of the gaseous molecule. Okay, so the remaining properties of liquid we will see in the next lecture. Today we have completed the properties of air. Now in the next, so students, in the today's lecture we have completed the properties of air. Okay. In the next lecture, we will start the properties of the next natural resource, that is properties of water. Okay, thank you friends.